Wait. Before I start today's video, let me add a disk to our Ubuntu server. Okay, now we can start. Linux can swap memory pages from RAM to disk as needed, storing them on a separate space, usually implemented as a separate partition on a disk, called the swap partition or simply swap. This partition needs to be of a specific type and set up with a proper utility, mkswap, before it can be used. The swap partition cannot be mounted like the others, so you cannot access it like a normal directory. A system can have multiple swap partitions, and Linux also supports the use of swap files instead of partitions, which can be useful to quickly increase swap space when needed. Before creating the swap partition, let's try to understand the current state of memory in the machine. Free-m displays the amount of free and used physical and swap memory in the system. We can list the partition layout on all block devices with parted-l. At the moment, there are 2 GB of swap allocated inside the disk dev SDA in partition SDA5. As you can see, the file system for this partition is Linux swap. We can create the swap partition by using different commands based on the partition table we want to use. For example, fdisk, gdisk, and parted. The procedure is the same for creating a regular partition. In this tutorial, I'm gonna use parted. The goal is to add a new swap partition stored in the just added disk /dev/sdb. Keep in mind that using an entire disk as a swap partition is not common, but it's fine for this tutorial. Let's create the swap partition by passing the new disk as parameter to parted. First of all, it's necessary to create a new disk label, aka partition table, of GPT type. Next, we can create the new partition by typing mkpart. It should be identified as a swap partition during creation, so just use Linux swap as the file system type. As I said before, we want to allocate the entire disk for the swap partition. Once the partition is created and properly identified, just use mkswap followed by the device representing the partition you want to use, like mkswap/dev/sdb1. To enable swap on this partition, type swap_on followed by the device name. Note that the total swap is now 3 GB because we just added 1 GB of the new swap partition. It's possible to specify the priority of the swap device. Higher numbers indicate higher priority. We have to disable the swap partition and re-enable it again with the new priority value. So similarly to swap on, swap off followed by the device name will disable swap on that device. We can now run swap on command by specifying priority value. In this example, dev SDB1 will be engaged before of dev SDA5. Using these commands, The swap partition will be used only during the current system session. If the machine is rebooted, the partition will still be available but will not be automatically loaded as swap partition. You can automate that by adding the new swap partition to etc fstub. In the default fstub file, there is the swap partition created during the installation of the operating system. To add the new swap partition, simply insert a new row into etc fstub file. Important: please use UUID instead of the label /dev/sdb. UUID stands for Universally Unique Identifier, and it is used in Linux to identify disks and partitions. But how can we retrieve the UUID? Well, we can use the blkid command. blkid gives you the UUID of a specific device. The advantage of using the UUID is that it is independent from the actual device number the operating system gives your disk at boot time, which may be different on subsequent boots. However, in modern Linux distribution, it's strongly recommended to use systemd units to automatically mount partitions when the system boots. For this purpose, systemd provides a specialized .swap unit file type which may be used to activate swap. The file name of swap unit must reflect the mount point path and has to be escaped with systemd escape command. Once created, you simply have to start and enable the new swap unit. Also, you can specify the priority of the swap partition by adding the priority property into the unit configuration file. Linux also supports the use of swap files instead of partitions. Just create an empty file of the size you want using dd and then use mkswap and swapon with this file as the target. The following commands will create a 500 megabytes file called swap file1 in the current directory, filled with zeros, and then set up and enable it as a swap file. Both mkswap and swapon will complain if your swap file has insecure permissions. The recommended file permission flag is 0600. Owner and group should be root. Linux swappiness is the rate at which a Linux kernel moves pages into and out of active memory. The Linux platform does not wait until all available memory is used before swapping pages to disk. Instead, it swaps pages based on how long they have been inactive. Increasing the swappiness value makes the Linux kernel move inactive memory pages to swap sooner than when the swappiness parameter is low. You can change swappiness by running the command sysctl vm.swappiness equal and then the value of the swappiness that you want to set. To permanently change the swappiness, add into etc sysctl.conf the parameter vm.swappiness with the proper value, for example 80. I suggest you to create a dedicated file for the swappiness inside etc sysctl.d folder called, for instance, 80 swappiness.conf, in order to avoid to directly change sysctl.conf. Again, to make changes persist, let's create a systemd unit for the swap file. Let's finish this overview with a simple RAM load test just to see how swap space is used with the configuration done so far. Thank you for watching and see you in the next video.